When doing preliminary research, it was important to our group to find research that supported the need to close the gap between the student and teacher barrier. We had found meta-analysis done by the International Journal of STEM Education that had showed that including game type and game methods in STEM education effectively improved learning gains in students, which gave us the confidence to continue with our project. For our project design, we had decided to create a math game. This game would display addition and subtraction problems and be used as practice in a classroom setting. We felt that this design helped to close the gap between the student and teacher because, as the meta-analysis found of using games in the classroom, we felt that this game would keep students engaged while they practice addition and subtraction problems.
This video shows the assembly of our first prototype. One of the problems with this prototype was that it seemed less effective than something that could connect to the internet like a phone, as it had multiple devices that might confuse someone. It also wasn't solving our problem, but rather was just identifying issues within our problem space.
The C++ code for the project here controls how the camera will move around with the character, as it won't be affected by the inputs that the user inputs into the video game. And also, the code here also controls the movement of the character. For example, the jump velocity for get character movement is set to 600, and the gravity scale for the game is set at 2. And that controls how fast the character falls back down to the ground. And also, there are some user-defined functions that are used for the animation of the character, and it decides which animation will play during which movements. And also, there are user-defined functions that determine what actions the character does depending on what input is given by the user. The C++ code does not control everything within the game. In the Unreal Engine, you can use things called blueprints to control how things in the game function based on user input. For example, for the home screen, we have a widget that says on clicked the how to play button. It sets the visibility of the main menu to hidden, and then it sets the options menu to visible, which will then show the player how to play the game. And similarly, on the back button, it brings back the main menu and makes the options menu invisible. And also, the start button opens up, when you click the start button, it opens up the level, and then the get player controller allows for the cursor to become invisible, and then it sets the game mode to the actual level of the video game. Here we have the blueprint for the jump pad. It starts off with actor begin overlap. Actor begin overlap is essentially that the hitbox of the character is intersecting with the hitbox of the jump pad. So, when the game calculates that those two boxes are intersecting, it is going to cast to the character a velocity upward. In this case, we have a velocity of 1800 upwards. And that will send the character flying up into the air. And as the character is flying up into the air, we have a function to play a sound at the location, which is just the boing sound. And we also have to set the location as self, as the sound will be coming from where the jump pad is. Finally, here we have the blueprints that represent how the user is brought to the end screen. So there is a trigger box at the end of the level so that when the character intersects with this trigger, this function is called, that opens up the level end screen. And once the user is taken to the end screen, they're able to exit the game there, and that's where the video game ends.
In order to test our final design, we had decided to reach out to a few people to play our game to make sure it worked and was easy to understand. If given more time and resources, our group ideally would have liked to reach out to first grade classroom settings and get our game tested by our target audience, which was first graders and their teachers. Through testing college-age students, we were still able to successfully test whether the game was engaging and rewarding for students, which both came to be positive. When looking at our timeline, we decided to stick to a strict deadline format which mimicked the deadlines in the project file. As a group, we met to work on the design of Prototype 1 and met to build the prototype together. Prototype 2 and 3 were worked on individually and put together. Not shown in the Gantt chart is the timeline for the final design, which was the total of the 3 prototypes together and with some extra time to refine up until the week of the 17th of April. Since we have a computer-based project, our total expenditures actually came out to be $0.